So let's break down system design. We're going to go from just one user all the way to a million. Because look, this is the exact skill that really separates mid-level developers from the seniors out there. Every huge system starts out simple. We're talking everything, your whole app living on just one single server. So what happens when you type in a domain? Your request goes on a little journey to the server and back. Okay, traffic is growing. Now you've got to choose, make your current server stronger or just add more servers. For most big apps, adding more servers is the way to go. It's just way more reliable and flexible. Okay, with more traffic comes more data. That means picking the right database is absolutely critical. Choosing between SQL and NoSQL really depends on your data's structure and what you need performance-wise. All right, you've got a bunch of servers, so how do you actually send traffic to them efficiently? That's where a load balancer comes in. Think of it like a traffic controller for all your servers. The easiest way is round robin. It just sends each new request to the next server in line. Super simple. Or you could send traffic to the server that's the least busy. This is great for varied session lengths. Then there's IP hash. This makes sure a user always gets sent to the same server. Really useful for sessions. Load balancers also run health checks, so they can automatically redirect traffic if a server goes down. Okay, so how do we get all these different parts of our system to actually communicate with each other? We do that with an API. It's basically a contract that lets software components talk without knowing the messy details. And there are different styles of API, each one with its own strengths for different kinds of communication. Last but not least, a scalable system has to be a secure one. So how do you protect it? APIs face a ton of threats, from data theft with injections to tricking users into running bad code. We fight back with things like rate limiting, firewalls, and just plain secure coding practices to stop these attacks. So building the system is one thing, but making sure it can keep evolving, well, that's the real challenge.